Okay. So we're going to make an xy chart first. So plugging in values for x, the sine of 0 is 0. The sine of pi halves is 1. Sine of pi back to 0. Sine of 3 pi halves, negative 1. Sine of 2 pi back to 0. So that's why when we graph it, we have the sine of 0 is 0, 1, or pi halves is 1, pi back to 0, 3 pi halves to negative 1, 0 to 2 pi. You get that famous, lovely curve. Now, if we want to graph the inverse of this, notice our function is passing a vertical line test just fine, but it's not passing a horizontal line test right there. So its inverse won't be a function. When we swap the x and the y, it'll double back on itself, which is bad. So that's why we have those silly restrictions on inverse sine, and we're going to restrict it between negative pi halves and pi halves, because what we see is if we take it backwards a little bit, so if I plug in negative pi halves and negative pi, so the sine of negative pi halves is negative 1, and the sine of negative pi is back to 0. So negative pi halves, negative 1, back to 0, and it's looping around the other way. Now, here it starts to fail too, but what we see is if we restrict our domain between negative pi halves and pi halves, then that will pass a horizontal line test, so when we invert it, we'll have a function. So when I go to graph y equals the inverse sine of x, the inverse function just inverts the x and the y. So, and I want to do it between negative pi halves and pi halves. So instead of plotting 0, 0, I'll plot 0, 0. That point's going to stay. Instead of plotting pi halves 1, I'll plot 1 pi halves. So 1 here is a little less than pi halves, and then I'll go up to pi halves, which is a little bit more than 1. And so I'll stop there. And then I'll plot 0 pi. So if I plot 0 and pi is like 3.14, I'm there. And actually, I didn't want to go that far, I'm sorry. I said I was going to stop at pi halves. So got that. And then if I plot negative 1 pi halves, so negative 1 and it's about negative 3 over 2, so it's like negative 1.5. I'm down here. And so what that does is we've got this little guy going on there, and that's your inverse sine graph. It's going to kind of come and loop along this side to keep going and loop along this side. So it's nice and symmetric over that line y equals x. A little messy. I'll see if I can get some principles of nice ones for you, but that's how you do it. We know it forward, and we just swap them to go backwards. Let's do the same thing for cosine, see if that gets any prettier. So the cosine of 0 is 1, cosine of pi halves is 0, cosine of pi is negative 1, 3 pi halves is back to 0, 2 pi back to 1. So 0, 1, pi halves 0, pi, negative 1, 3 pi halves 0, 2 pi 1. So, and it's got this curvature in it. My teacher talked about it as being like a nose over a fence. So it is kind of like it is just a shifted sine. So it's got that same curviness, just shifted. Now, cosine, we don't want to have the same restriction here because between negative pi halves and pi halves, it's failing the horizontal line test there. So when we do our inverse, we're going to restrict it from 0 to pi. So if we restrict it to 0 to pi, this little red part does pass a horizontal line test. And here it would start coming up, so that's where it would start to fail. But if we just take that segment, we'll be okay. So just from 0 to pi, I'll invert those. So instead of plotting, when I go to plot the inverse cosine, instead of plotting 0, 1, I'll plot 1, 0. Now 1 is less than pi halves, so that's there. and then I'll plot 0 and pi halves, like 1.5, and then I'll plot pi, no, I'll plot -1 and pi. So -1 and 3 1/4, so I'm up there. So then it's looking a little something like that. And again, I'll get you something nicer. Oh man, I can't draw. But, okay. And if you were to keep going, it would just crawl up and down the axes, and it would be nice and symmetric over the line y equals x. So I'll get you some downloads of prettier pictures of that, but hopefully you get that's the idea of how to graph them. Cool. Oh, and I think the problem that they asked you, the reason I did this was for number 7, they asked which function this was, and clearly it's not sine or cosine, but it's going to be, that one looks like the inverse sine. So for 7, your answer is C. So 7, C.